Hello, my name is David Sousley, and today I will be giving a presentation on AppArmor and the HTTPS protocol using IIS and Apache. AppArmor is an LSM based on the Mac model that confines applications to a limited set of resources. AppArmor uses an ACM based on security profiles that have been loaded into the kernel. Each profile contains a collection of rules for accessing various system resources. AppArmor can be configured to either enforce access control or just complain about access control violations. AppArmor proactively protects applications and operating system resources from internal and external threats, including zero-day attacks, by preventing both known and unknown vulnerabilities from being exploited. AppArmor has been built into the mainline Linux kernel since version 2.6.36 and is currently shipped with Ubuntu, Debian, OpenSUSE, and similar distros. With AppArmor, processes are confined and restricted by profiles. AppArmor profiles are loaded upon system start and either run in enforce mode or complain mode. So in force mode, AppArmor prevents applications running in enforce mode from performing restricted action. Access violations are signaled with log entries in syslog. Ubuntu by default loads the application profiles in enforce mode. With complain mode, applications running in complain mode can take restricted actions, while AppArmor creates a log entry for the related violation. Complain mode is ideal for testing AppArmor profiles. Potential errors or access violations can be caught and fixed before switching the profiles to enforce mode. Now this command here, sudo space AA tac status, will check the status of AppArmor. That will show the number of profiles. Now we will go over some hardening recommendations. AppArmor is a security hardening framework designed for Ubuntu that lets you place restrictions on how individual programs can behave and which system resources they can access. The intended purpose of AppArmor is to mitigate the extent of a breach by ensuring that even if attackers are able to take control of some of the software on your computer, for example, convincing you to install malware on your system, the damage they can do will be limited because the software won't have free reign to essentially do whatever it wants. AppArmor is a complicated tool, and a full explanation of how to use it is beyond the scope of this presentation. But first you need to install it and then go through the Ubuntu documentation, be able to offer more details. On most Ubuntu desktop systems, AppArmor is probably overkill. It's probably not worth learning to configure AppArmor if you're just a regular PC user. But on Ubuntu servers, however, taking the time to learn to work with AppArmor is a smart way to harden your system against attacks. Effective hardening of a computer system requires minimizing the number of programs that mediate privilege, then securing the programs as much as possible. With AppArmor, you only need to profile the programs that are exposed to attack in your environment, which drastically reduces the amount of work required to harden your computer. AppArmor profiles enforce policies to make sure that programs do what they're supposed to do, but nothing else. AppArmor provides immunization technologies that protect applications from the inherent vulnerabilities they possess. After installing AppArmor, setting up AppArmor profiles, and rebooting the computer, your system will become immunized because it begins to enforce the AppArmor security policies. And protecting programs with AppArmor is called immunizing. Administrators only need to concern themselves with the applications that are vulnerable to attacks and generate profiles for those. Hardening a system comes down to building and maintaining the AppArmor profile set and monitoring any policy violations or exceptions logged by the AppArmor reporting facility. Building AppArmor profiles to confine an application is very straightforward and intuitive. It doesn't require any programming or script handling, and the administrator is really only required to determine a policy of strictest access and execute permissions for each application that needs to be hardened. There are several components and syntax of profiles. So there's including files, abstractions, program chunks, capability entries, network access control entries, local variable definitions, file access control entries, and R limit entries. And now we're going to introduce HTTPS, which stands for Hypertext Transfer Protocol Secure, and it's an extension of the Hypertext Transfer Protocol, and it's used for secure communication over a computer network and is widely used on the internet. In HTTPS, the communication protocol is encrypted using transport layer security. So between HTTPS and HTTP, HTTPS is on port 443, and essentially the big difference between HTTP and HTTPS is that extra S, which stands for security. One is an encrypted connection, the other not being encrypted. And the SSL certificate is used with HTTPS, and that adds that extra layer of encryption. HTTP is faster, however, but less secure. So if you're going to be accessing a banking site or using credit card information, you should be using an HTTPS connection. So IIS stands for Internet Information Services, and it is an extensible web server software created by Microsoft for use with the Windows NT family, and IIS supports HTTP, HTTP2, HTTPS, FTP, FTPS, SMTP, and NNTP, and it's been an integral part of the Windows NT family since Windows NT 4.0. It's absent from some editions, like Windows XP Home Edition, and it's not active by default. Some hardening recommendations: should disable unnecessary services. This reduces the possibility of potential attack by disabling any features of IIS you're not using. So for instance, there's no need for the FTP service to be turned on if you're not using it. And request filtering means you can grant access to your internal domain and add any other person to your access list. Logging, you can use logging to see visitors who have been accessing the web server. And turning on this setting can help you track whenever you suspect someone has been using your server behind your back. You can monitor these logs for events that may point to your server misbehaving. Apache is the most commonly used web server on Linux systems. And web servers are used to serve web pages requested by client computers. And the configuration is termed LAMP, so Linux, Apache, MySQL, and Perl, Python, PHP, and forms a powerful and robust platform for the development and deployment of web-based applications. And Apache is open source and free web server software that powers around 46% of websites around the world. Some hardening recommendations: hiding the e-tag header. The e-tag header involves quite a significant number of sensitive details regarding your server. It's interesting that for PCI compliance, it is required to hide the e-tag header. And to achieve this, you enter this command, and disabling CGI and SSI. And these are directives present on web applications used to feed an HTML page with dynamic contents. They're also capable of opening your website up to a certain number of security issues if left unchecked. The same case happens for the CGI scripts, so as to prevent hackers from injecting malicious scripts in your code. And here is the command you're going to run to do that. And setting the HTTP limits can defend against DDoS attacks. And this is the commands that you are going to do for that. And thank you for watching today's presentation.